So you will find in calculus that it's often helpful when you have a bunch of variables floating around to try and write them whenever possible as power terms, that is to say where there's a coefficient and then x to some power. So let's practice that with some of these. Oftentimes it's just using your properties of exponents. So first things first, looking at this one, I might probably want to recognize my coefficient. My a first would be 1/5. And then remember, since this x to the third is on the denominator, I can pull that up by making it negative, right? If it's on the denominator, that means I had a negative exponent, so that would be x to the negative third. So 1/5 x to the negative third plus, and then this one's even easier. I've already got my power x to the fourth, and then I just need to recognize, I can put a little 1 there, that my coefficient is 1/3. So 1/3 x to the fourth. Okay, next one's a little trickier. So first of all, you remember from your properties of exponents that when I have a radical, I can write that as what we call a rational exponent, or like a fraction. So the cube root of x, for example, would be x to the 1/3, and that's divided by x. And then here I have x times, and the square root of x, we said, is x to the 1/2. Now still we've got two x's in each term, so let's keep simplifying. Remember, when you're dividing two powers, you can subtract the exponents. So think of this as x to the 1. I want to subtract 1/3 minus 1, and in case you forgot your fractions off to the side here, 1/3 minus 1, right? Remember, you need a common denominator, so you multiply by 3/3. So that's really 1/3 minus 3/3, and then 1 minus 3 I can subtract, I get negative 2/3. So this would be 5x to the negative 2/3. And then here I'm multiplying, first let's say, so I'm multiplying two powers, and so this time I have x to the 1 times x to the 1/2, and to multiply, again, you add the exponents, so I want to do 1 plus 1/2, and again get that common denominator, so that would be 2/2, so I have 2 halves plus 1/2, which is 3/2. So I have x to the 3/2, and then again, because think of this as a 1 up top, my coefficient would be 1/2, or 1/2. All right, moving on. So on this third example, notice that you've got your power terms here, but there's this big division bar, and we want to sort of get rid of that. So notice that these are both being divided by 2 root x. So I can split this up as long as I divide them both. So I have 6x squared divided by 2 root x. And by the way, again, instead of writing the square root, I'm going to write the 1/2. So 2x to the 1/2 minus, and we've got 10x cubed over 2x to the 1/2. And now I can divide these to get my coefficient. So I've got 3. And then remember, with the powers, you're dividing, so you subtract. So again, I'll write it out. If I'm doing 2 minus 1/2, need a common denominator, so I multiply by 2/2. So that's 4/2 minus 1/2, which is 3/2. So this is 3x to the 3/2. Minus, again, my coefficient would be 10 divided by 2, which is 5. And then I subtract the exponents. So this time I'm doing 3 minus 1/2, multiply by 2/2 to get my common denominator. So that's 6/2 minus 1/2, which is 5/2. So 5x to the 5/2. And now I'm done with that one. All right, last one's a little bit different. Notice this time the issue is that I've got the exponent outside of this binomial here. And please remember, you can't just distribute that because these are added. You cannot distribute exponents over addition. Because what 2x plus 3 cubed means, of course, is I have 2x plus 3 times another 2x plus 3 times another 2x plus 3, and this 4 to distribute out here. And so I really have to actually multiply these out. We'll do it one step at a time. Let's start with these two. You could use FOIL, remember your first, outer, inner, last, but since I did that on the last example, the other method that probably a lot of you learned is using the box, so you can use that as well. It doesn't really matter. If I want to multiply 2x plus 3 times 2x plus 3, Remember, I just multiply 2x times 2x would give me 4x squared. 2x times 3 would give me 6x. 2x times 3 is 6x, and 3 times 3 is 9. So this part right here gives me 4x squared. 6x and 6x adds to 12x plus 9. And then I've still got the other 2x plus 3, and I've still got this 4 out front here. Okay, so now to multiply these two together, I can use the box again, but this time I'll just make it a little bigger because I've got my 2x plus 3 on the one side, and then on the other side it's going to be 4x squared plus 12x plus 9. So 2x times 4x squared would give me 8x cubed, right, because 1 plus 2 is 3. 2x times 12x would give me 24x squared. 2x times 9 is 18x. Then I've got 4x squared times 3 is 12x squared. 12x times 3 is 36x. And 9 times 3 is 27. So that was these two multiplied together. So, putting that all together, I have my 8x cubed. And again, usually we can add along the diagonals here. 12x squared and 24x squared would give me 36x squared. 18x and 36x would be 54x, and then plus 27 at the end. And then finally, don't forget we have that 4 out front that we have to distribute. So distribute that, and I will have, let's see, 32x cubed plus 144 x squared plus 216x, and then that would be 108. And now I'm done.